Welcome to day 6 video 3.3 increasing, decreasing, and the first derivative test, part 1. Okay, so we're going to talk about increasing and decreasing when the function is increasing and decreasing, and we'll be able to do this by looking at the first derivative. And then we're going to talk about the first derivative test, which allows us to find if there's any relative extrema on the interval. So to get started, let's just define what monotonic functions are. Okay, so monotonic functions are always increasing or they're always decreasing. Okay, so it's one or the other. All right, now to determine if a function is increasing or decreasing, we can go ahead and look at the first derivative. So we're going to let f be a function that is continuous on the interval, closed interval a to b, and differentiable on the open interval. So if f prime, if the derivative is positive for all x on that interval, then the function is increasing. If f prime, or the derivative, is negative on that interval, then f is decreasing. If f prime equals 0, then f is constant. Okay, so if you take a look, and remember, f prime acts like our slope. It's related to our slope, right? So if we're looking at this diagram to the left here, our function is decreasing and our first derivative is negative. Here we're constant, our first derivative, f prime, is 0. And to the right, we are increasing, f prime is greater than 0. This leads us to the first derivative test. So if c is a critical number of a function f that is continuous on the open interval containing that point c. Okay, so we have to think that is happening. If f is differentiable on the interval, except possibly at c, it could be undefined there because we're talking about a critical number, then f of c can be classified as the following. We can say f prime of x changes, or if f prime of x changes from negative to positive at that point c, then f has a relative minimum at that point. So for instance, if we look at this first diagram, okay, f prime is negative and then it changes to a positive. So if this is our critical number, we could go ahead and say that we have a relative minimum there. Another thing we should note is when f prime is negative, f is decreasing, okay? And when f prime is positive, f is increasing, okay? So that's the first scenario. Scenario number 2, if f prime changes from positive to negative at c, then we have ourselves a relative maximum. So that's this diagram right here. F prime goes from positive to negative. So that means f goes from increasing to f goes to decreasing. In that scenario, we have ourselves a relative maximum. If f prime is positive on both sides of c or negative on both sides of c, then f of c is neither a relative minimum or a relative maximum. Okay, so that means that c point is a critical number, but it's not a relative extrema. So for instance, f prime is positive, so that means f is increasing. And over to the right of c, f prime is positive, so f is still increasing. So there's no relative extrema there. Same goes for the diagram on the right here. F prime is negative to the left of c, so f is decreasing. And it's still negative over here, so f is still decreasing. So even though we have a critical number, it's not a relative extrema. Let's look at a few examples. This first one is just identifying the intervals for which the function is increasing or decreasing, and we're looking at the open intervals here. So hopefully you can identify this pretty easily. Looking at it, we are increasing on the interval from negative pi over 6 to 7 pi over 6, all right? And what we should notice is f prime would be positive there. We're also increasing from 11 pi over 6 to infinity, okay? And we're decreasing, f is decreasing here. F prime is negative, you could be able to tell that. on the interval from 7 pi over 6 to 11 pi over 6. This next example wants us to apply the first derivative to identify any extrema, okay, any relative extrema. So whenever I see that, the first thing we need to do is find any and all critical numbers of f if there are any. So by doing so, we need to find the derivative, right? So here's our function f of x equals x to the 4/5 plus 1. Finding the derivative, we get 4 over x to the 5x to the 1/5. Now remember, critical numbers are found by setting f prime equal to 0 or determining when f prime doesn't exist. F prime will never equal 0, but it is undefined when x equals 0. So our critical number is when x equals 0. Now we're going to apply the first derivative test to identify any relative extrema. So what we do here is I draw this little number line, okay? And I identify where my critical number is, and I kind of cut that line accordingly, okay? So I label my critical number. From there, I need to determine my f prime value. So I pick a point for x on this interval to the left of my critical point, my critical number, and I pick a value of x to the right of my critical number. Now I plug this value back into my derivative from up above. So when we plug in x equals -1 into our f prime function, we should see that it's negative. So I just put a little minus there. Now I choose a point on this interval. So I'm going to choose when x equals 1. When I plug x equals 1 into our derivative up above, I'm going to get a positive value. So I put a little plus sign there. Okay, so remember, if f prime is negative, what does that mean about f's behavior? So now I just make a note. When f prime is negative, that means f is decreasing. When f prime is positive, that means f is increasing. So what happens now when f goes from decreasing to increasing? Well, we should be able to identify that this right here is going to represent a minimum. So in conclusion, we could go ahead and say by the first derivative test, FDT is how we will abbreviate that, there is a relative minimum at x equals 0. And our conclusion is based on the fact that f goes from decreasing to increasing. Let's try another one. So now we're given the function f of x equals x minus 1 to the 3/5. Okay, we want to find any relative extrema by applying the first derivative test. So the first thing we have to do is find what f prime is. All right, after we go through the motion, we get f prime is equal to 3 over 5 times the quantity x minus 1 to the 2/5 power. Finding our critical numbers, it's either when f prime equals 0, in this case it will never equal 0, or when f prime does not exist. In this case, it's when x equals 1. So our critical number is when x equals 1. So now we can apply that first derivative test by drawing in our number line. I identify my critical number and I kind of split my line accordingly. I find my f prime value by plugging into our function up above. So I chose when x equals 0, plugged in 0 for x into f prime, and I got a positive value. So since f prime is positive, I can then make the conclusion that f is increasing. Now I choose when x equals 2, so I plug that into f prime, and I get another positive value. So f prime is positive here, which means f is still increasing. So since f is increasing on that entire interval, our conclusion is, by the first derivative test, FDT, since f is monotonic, remember that's always increasing or always decreasing, there is no relative max or min at this point. Finally, our last example. Again, we're going to apply the first derivative test to find any relative extrema. So if we are given our function, f of x equals 1/2 x minus sine of x, now we're looking on this interval here from 0 to 2 pi. First, find the critical numbers. So when I'm asked to find the critical numbers, I always think first derivative. Okay, so we need to find the first derivative. So first derivative of 1/2 x is 1/2. The derivative of sine is cosine. So here's our first derivative, and we know to find critical numbers, it's either when first derivative equals 0, and in that case, I set it equal to 0, and I get two values, pi over 3 and 5 pi over 3. It's also a critical number when f prime is undefined. In this case, it will never be undefined. So we have two critical numbers this time, pi over 3 and 5 pi over 3. I want you to set up your number line right now, apply the first derivative test, determine what f prime value is on those intervals and the behavior of f, and see if you can make a conclusion. So pause the video now and try it. Come back and check your answer. Since there were two critical numbers, and we're on our interval from 0 to 2 pi, we end up having three intervals that we need to check for f prime. So I chose pi over 6 to plug in for in f prime in this interval, and I got a negative value. When I tested pi over 2 into f prime, I got a positive value. When I tested 11 pi over 6 into f prime, I got another negative value. So when f prime was negative, I knew f was decreasing. When f prime was positive, I knew f was increasing. And when f prime was negative again, f was decreasing. So I was able to tell, since f went from decreasing to increasing at pi over 3, we have ourselves a relative minimum. And since f goes from increasing to decreasing at 5 pi over 3, I know we have a relative maximum. So I was able to make the conclusion by the first derivative test, we have a relative minimum at x equals pi over 3, since f goes from decreasing to increasing, and a relative maximum at x equals 5 pi over 3, since f goes from increasing to decreasing. If you have any questions on today's video, let me know and we'll talk about it in class.